Hello everyone, I'm Chavi and welcome to the playlist of data science. We have covered various topics before. Now we have a new topic called naive Bayes classification. So in this video, we'll study about the naive Bayes classification. This presentation explores naive Bayes classification, a powerful probabilistic method widely used in machine learning for classification tasks. We will dive into its core concepts, implementation, and real-world applications as we uncover the simplicity and effectiveness of this versatile algorithm. Right? So let's dive in. Introduction to naive Bayes. What is it? So what is naive Bayes? Naive Bayes is a probabilistic classification algorithm based on Bayes' theorem. It classifies data points by calculating the probability of each class given the observed features. Right? So what is naive assumption? It assumes that all features are independent of each other, which is often not entirely true in real world data. So why do we use naive Bayes? Right? Despite the simplifying assumption, naive Bayes performs remarkably well across various classification tasks. It's known for its simplicity and effectiveness, particularly for text classification and spam filtering. Right? So what is the steps of naive Bayes theorem? Prior probability, the probability of the class without considering any features. Likelihood, the probability of observing the features given the class. Posterior probability, the probability of the class given the observed features. Right? The probability of observing the features. Okay. So moving on to the next topic, maximum a posteriori hypothesis versus map hypothesis. The class with the highest posterior probability is chosen as the most likely class of the given data point. Next is calculation. The algorithm calculates the posterior probability for each class and selects the class with the highest value. Decision. The map hypothesis provides the basis for making classification decisions based on the most likely prediction. Right? Class conditional independence. First is feature independence, simplification, and benefit. Feature independence includes naive Bayes assumes that each feature is independent of other feature given in the class. Now, simplification. This assumption simplifies the calculation of likelihood probabilities by treating each feature as independent, even if it may not be true in reality. And benefit. Despite the specification, naive Bayes often achieves surprisingly good performance due to its robust nature. Right. Next is application of naive Bayes classification. What are the application of naive Bayes classification? Spam filtering, medical diagnosis, document classification. What is spam filtering? Identifying unwanted emails based on word frequencies and patterns. What is medical diagnosis? Predicting diseases based on patient symptoms and medical history. Next is document classification, categorizing documents into different topics based on their content. Now is naive Bayes in Python. How to use naive Bayes in Python? First is import libraries, import necessary libraries like scikit-learn for building the model. Load data, load your data into a suitable format, separating features and labels. Third is train model, instantiate and train the naive Bayes model using the training data. Next is make predictions, predict the class labels for new data points using the train. So this is all for today. We have covered naive Bayes classification. Meet you in the next video with another new topic. Thanks for watching. Please subscribe, please hit the like button, and please hit the bell button for the notifications. Thank you.